This course is very unique and it's a foundation course. It means that whatever we'll do in future, uh, it will touch this course somewhere or other. Okay, and so we'll see what are the motivations for this course because you know all of you are going to become computer engineer or software engineer, and systems engineering will touch you somewhere or other. Whether you just go into pure programming kind of job or you do PhD, but systems engineering will always be very important. And this course, although it's named as computer architecture, but actually it's a computer systems engineering because computer organization or computer architecture course, we designed say 20 years back, and since then, the whole organization or definition of computer itself is changed, right? I mean, like my mobile my mobile has a processor this more powerful than supercomputer of 1960s or 70s. Okay? So with this, I think I will change the syllabus that was because syllabus is just four bullet points given to me, but we'll try to include whatever is relevant and interesting, and at the same time, it will help you in getting a job. Okay. Um, so all along, I will try to cover some topics that are more relevant to all of us today in order to get a good job. But at the same time, you have all the right to tell me if you want me to include certain topics and delete some certain topic or not cover certain topics. Okay. Uh, so let's keep the course very dynamic, and I will try since I have a good TA available this time. I will like to give large number of assignments to you guys, right? And the assignment or programming assignments are the way you will learn this course. Okay, all right. So basically, we'll have three lectures a week. Although this slot is not the greatest slot, 2 o'clock soon after you would have finished your food. Um and then body actually goes into a little bit of relaxation mode of sleep mode. So maybe before a class, you just do a little exercise, maybe stretch your body and relax, or maybe just do one or two push-ups and do some kind of breathing exercises, and you will be alive in the class. Because being alive is very important, right? Being alive and attentive. Okay. So we'll have three lectures a week, and if you want me to slow down, I can slow down. Okay. It means that sometimes students do feel that they are not able to cope up with the pace at which teacher paces the lecture. Uh, so I mean, it's all the reason for a teacher to slow down in because this is again a remote uh, way of teaching, not very effective, but let's do our best. All right. So we'll have three lectures a week, one lab of 2 hours. Okay, we'll give a home assignments every week. Okay, now this may be too much, you may think, but this will at least force you to learn. Okay, because so whole idea of having a course is to learn about something, right? Otherwise, online resources are available. So until you do hands-on job, until you do reading by yourself, very unlikely that you will learn enough. Okay, we will have two midterm exams and one end term exam. Okay, so basically three main exams, and then we will have a large number of quizzes. We call it concept quizzes, basically based on certain topics. Okay, now I will emphasize very much on your class attendance. Now I had discussion with many people in the organization, and it turns out that uh, attendance is in general very low. And at the same time, we realized that our students, 50% of students couldn't get job this year. This is very sad state of affair. Okay, and turned out that when even best profs classes, less than 50% students are available. Then question is that what for anybody is teaching if people are not ready to receive it, right? So I think that it's very important for you to attend the class, and if you don't attend, understand anything, I'm ready to take the classes n number of times, and could be as high as 10. Same thing I can repeat for 10 times for you guys if you are not able to understand anything. But not coming to a class is not acceptable to me. Okay, all some may say that internet is not working, etc. But I don't believe it today. Connectivity in the country is good. I am sitting in remotest place, that's in Goa, there's Dhavli, Ponda. It has only BSNL, one of the worst network that can have. Okay, so anywhere in the world, including the Himalaya where I went for trekking, we had better internet. Okay, so please attend the classes because that's very important. Otherwise, there's no motivation for me to teach you guys. Okay? And I had discussion with director and they agreed that make it mandatory. So, so please, whole objective is learning. Then you have to cooperate. Otherwise, it would be another course without any interest from anybody, right? Okay, we'll use various tools. Uh, GitHub, I will create some pages. Uh, Google Class, we started using it. Although I wanted to use Moodle, but till yesterday I couldn't succeed in getting it up for this class because there was some old data and I can't overwrite over that. Uh, okay, video conferencing, we'll be using Zoom or BlueJeans. So BlueJeans is interesting software developed in US. It is US based company, and Airtel is providing services now for free for some time. So I thought let me try this because at least some universities I know like GTech, BlueJeans is being used. Uh, Okay, and I would also request you to create a Linux VM over your laptop, right? So you can create any virtual machine. I have created Oracle's virtual machine. So if you want, I can send you steps for that because you will be doing exercises on a lot of programming in C. We'll focus a lot on C because C is the most powerful high level language. Okay, and if you understand C well, then you can do programming in almost anything because it's like a powerful aeroplane. If you can drive that, of course you can do chota mota plane. So we will be using three books. Okay, uh, the main book is actually in the middle, which is Harris and Harris, uh, and the most beautiful book is of course written by the experts from Berkeley. The book is called Hennessy Peterson book, or now this or Peterson Hennessy. We are using Peterson Hennessy. There are two books, and Peter Hennessy is most relevant and good book. However, I think the second book is also used in universities because it goes into details. It's good for beginners. Okay, so and good thing is that it's based on the first book. And the author acknowledges it, right? I mean, David Patterson and David's book, Patterson Hennessy book is quite good, but this book has a lot more exercises. And the third book is possibly the best. It's rated one of the top 100 books on computer science. It's written by a professor of CMU, Brandt and Hellron. And they were teaching earlier computer architecture course, and they realized that computer architecture that is covered in universities has no relevance with industry because most of the students go to write software. Okay, then they decided to do this computer architecture course through programming. Okay, so that's the reason book says the programmer's perspective. So I read this book and few things I like, but only concern or only thing that I possibly didn't like is that it uses x86 microprocessor. So x86 based processors, of course, most of our laptops have x86 processor, but it's very complex. instruction set is very complex, right? So it's will it will introduce some level of complexity in the course. So we thought we'll do some exercises based on x86. However, so these three are important books, and all three are available in Indian reprint, not costing more than 500 rupees. Um, of course, I know you guys don't buy books, so you can get it wherever you want it from. Okay. Other three books which once in a while I will refer is this book on by Pratt and Patel. It's a nice book, but I mean, sometimes or other, when I don't understand things in main book or I want more detail, I go to this book. But you can also get this book if you want. I would recommend all of you to buy this book or get this book from somewhere. It's recently been written. It's called All of Programming. Okay, this guy, these two people were in CMU, and I think they have moved to some other university now. I think Duke, if I'm not wrong. And if you, I can promise you one thing, right? If you read this book and do exercises, you can get job almost anywhere, including Google. Okay, and now this is a big claim. May not be always true, but it covers almost everything that possibly an interviewer will ask in programming, right? Because I must have interviewed at least 500 to 1000 software engineers in my career, and most of the time I never went down into asking difficult questions on networking, say for example based on some aspects of internet or how routings work and so on. But usually most of the time when we take interviews we stick to data structures and programming. Okay, and if you know data structures programming quite well, then there's a good chances you'll crack the interview. So this book, if you read end to end, is more than sufficient. And this, of course, Cunningham Rich's book is the classical book, right? So if you have not read this book, please read it because and do exercises, then your understanding of computer systems will be very good, because this book not only covers programming language but also a lot of aspects how programming language will run over CPUs, right, or processors. Okay, so these are the books that I'm going to use for my notes, and I will be very dishonest if I say that you don't need to read books. Nowhere in the world it happens. Even some of the top universities where I've studied also, uh, professors have their notes, but these notes have limitations, right? These are, we use nowadays PPTs, uh, and PPTs can only be abstract version of the book or some content. So reading book will give you good knowledge. Okay, so please try to read books. Okay, and I will be using also large number of online resources. Uh, some of the courses are beautifully done in university like MIT, and then one in CMU, and also in, I guess in University of Utah. I have gone through some of these courses, tried to when I was trying to design the syllabus for this course, and these are very interesting places. And then there are a lot of class videos are also available, right? So uh, I would suggest, if you don't understand something in this class, you go to these videos and possibly you can get more insight into the topic. Okay, all right. So, okay, so computer architecture, as we briefly discussed, is science and art of designing computing platform. So we can say that in general, architecture is a way of doing certain things, right? And there are some basic design principles. Okay, so if you go to the basic first slide, that top slide, so this purpose of this photos that I've taken sometime or other is essentially to show you different architectures that have evolved over time, right? For example, if you go South Indian temples, Okay, like the one that's shown here is uh, in Madurai. Then you will see that there is a whole architecture around how to design temples. Okay, wherein if you go to North India, then temple designs are different. In Goa, it's very different design. Have when you go to some beautiful places, then you will find that architecture is very unique. Similarly, churches have different kind of architecture altogether. Okay, they are built on certain principles, a big hall and so on and so forth, right? While temples are built on totally different principles, right? There has to be deity and then sanctum sanctorium, and then there's places around, there's places for social activities and so on and so forth, right? So there's a whole Vastu Shastra, or there is a way how to design something, and it's based on architecture. Similarly, a mosque and other beautiful buildings around religion have evolved over time, and these are the architectures, right? So coming to computer science, we can say that is a way of designing system based on certain requirement. Okay, when we design, suppose you are given a task of designing a temple. Okay, then you look at the region where it is for, what deity it is, because there are different rules for different deities, and then you will create a structure around it based on certain social norms. Like in, for example, in Goan architecture is very different. Okay, wherein and there is a also kind of stamba or a tall building in front of temple, a pillar kind for certain things, right? I mean, so there are certain rules. Similarly, in computer architecture, we have to define set of styles of or rules to design it, and it's always design is always for a goal or say number of goals. For example, if you are asked to design an architecture for a mobile computing or mobile platform, then you will design a mobile with totally different design goals. Say, for example, your design goal will be battery life. Your design goal could be, video processing, because 90% time you will use mobile for watching videos and so on and so forth. And these designs goals are also continuously evolving, right? I mean, 15 years back, 15 years back, I was in Nokia, and then heading a group that was designing handset. Uh, and then that time, video was not an important aspect, right? It was mainly phone calls and few other things. Like there were some applications where video was nowhere, but today video is most important requirement for any mobile device. Okay, so there can be n number of requirements. It could be based on speed of processing. It could be based on say cost also, right? Or it could be based on a lot of other factors, availability of components, right? So it could one can always design a handset which is average in performance for average workload. So if you're asked to design a supercomputer, then it's totally different from designing a smartphone. So these fundamental principles, but however, the basic principles of design remains the same. Okay, uh, we'll look at some of these. Okay, I'm skipping this slide. You can go through it. So what we are going to do in this course is essentially we'll see what are different components of a computer and how do we interact to give you certain output that is based on what are the requirements. Okay. Uh, few slides on evolution of computer. We know that some 40-50 years back, processors were very primitive. When I started learning computers, so in Roorkee University there was a supercomputer, and then it was DAC-20 computer, and we used to get just half an hour terminal time per day. Okay, and the capability of DAC-20 is less than that of a ordinary headset or on a mobile phone that you will get today in market for 4,000 rupees. So technology has evolved so much in last 40, 50 years, 40 years. Um, you know, and I remember when we had first time internet in India, it was in IIT Delhi. Um, so we created a login ID and so on and so forth, and then we found that connectivity is not working. So we got the emails on floppy drive, floppy disk, floppy. We used to have floppy disk, and then couriered the floppy disk to some place in Bombay for emails to go. So things have come all the way from there to point today, wherein anybody, even somebody on a street, a poor person can have internet connectivity and 1 GB of data per day. So things have changed since then, right? And we'll see how and why. Uh, Now today, it's impossible for us to imagine something that we are buying that does not have a computer inside. Okay, and if you analyze what all you do during the day, you'll find that at least 90% of time you are using or touching computer somewhere or other, right? Say for example, I get up and then I do some meditation, and in order to do the meditation, I use a timer that will prompt me after 1 hour, and then the timer is of course on mobile. Then I read newspaper. I don't buy regular newspaper, so I have an iPad, and iPad I have subscribed to some magazines and so on and newspapers, and I read 2 3 newspapers. I do exercises, then yoga, and then I use yoga videos, right? And then I prepare for classes on laptop and giving classes on laptop. Entertainment is absolutely on it. I don't use Tata Sky or whatever. So everything is video on demand or news channels available on iPad or laptop, right? So and then you drive car. Today a car has about 100 plus microprocessors. Okay, so most of the things that we do today, whatever equipment we are buying, as a built-in processor. Why is that? Why do we need processor in everything? Because we need intelligence, right? And it becomes smarter. And once it gets connected to internet, right, you have accessibility from anywhere. And on top of that, it creates a lot of problem of security, right? So if everything gets connected to internet, anybody can hack your devices that are connected to internet. Okay, we'll cover some aspects of security also in this course. Okay, processors are cool. Now it's becoming cheaper and cheaper every day, right? Because fortunately, making processor does not require, very expensive material. We don't need anything apart from basic silicon. And we call it sand or rate in Hindi, right? And the second blessing that we have is that it's extremely pure. Now, normal sand that you get near sea or river is absolutely pure, right? Impurity is very little. So from this we create magic of making transistor, chips, and so on. And I think in your class somewhere or other you would have covered how to create chips, right? Okay, starting from wafer, uh, you you use some kind of mask to create transistors, and then finally these wafers are cut into chips, and then pins are attached. Okay, we are not going to cover all this manufacturing process in this course, but this slide is just to give you perspective on how chips are made. And technology is moving very, very fast. And of course, now it's slowed down. Now you can get transistors which are less than 10 nanometer in size, right? So in fact, now technology has moved from 10 nanometer to 5 nanometer. Okay, and 5 nanometer is hitting the ceiling. I mean, it's hitting, it's called some kind of wall, which is we call that power wall. We'll look at that concept later, right? So now this is the degree of integration that we have. Okay, so this chart shows the growth of transistor density over time, and so we are almost moving to 10 nanometer to 5 nanometer now. It means that we can pack more and more number of transistors in a chip or per square centimeter. Okay, and we'll look at the law governing this in the next class. Now, this announcement about this Intel Tiger Lake came just recently, just few days back. Okay, it has 4 cores. When we say cores, what does it mean? It means that it has 4 processors working inside chip. It's not a unique processor. Okay, and then it can have 8 threads. It has 3 levels of cache: L2 cache, L3 cache, and L1 cache. We'll look at what are the cache memory when we study memory hierarchy and what is the advantage of that. Okay. Processor speed is 4.8 gigahertz. Now you may find that processor speeds are not moving beyond a point, right? And we'll see why. GPU clock. Now each processor also have a GPU nowadays. Okay, because we do a lot of graphic related work. Okay, this one uses 10 nanometer technology and so on. So this is very latest chipset with very high transistor density. Now the question that you may ask that why should we study computer architecture? So the computer architecture that we are going to study will let us know how actually a computer works. Now, suppose your dad wants to use a laptop and he is not computer engineer, then he may not need to know any of these, right? Because as a user of a computer, computer gives you abstraction. Okay, the mobile is a computer, and when your father does WhatsApp, then he need not know what is the processor inside, what is the memory and what is the cache in this one, what OS it has, right? It may not, he may not know any of these, and there's no need, and that's the beauty of abstraction, right? So the user is exposed only to certain things, right? Hiding all complexities. So, however, as when you are going to write a program or design a program or design a system, suppose you are asked to design an application or self-driving car or something very interesting, then you need to know what is inside, because your program's performance will totally depend on what is inside, and the way you also do programming will depend, and how efficiently that program will run depends on what is inside. Okay, so of course all these points are very important, because without whatever area you get into, right, there will be concept of embedded processor somewhere or other. Okay? So if you know technology inside, you will be able to do better programming. Okay. You will also learn how computer hardware is going to be in future. What are the trends? Okay. How can you write better code, etc. Of course, performance very important. We'll also see why microprocessors are among the most sophisticated device manufactured by human beings so far. It's extremely complex, but the beauty of microprocessor is that it provides abstraction. So a person who is working on top of microprocessor may not need to know what is the data path, etc. Okay. You can design better systems, you can enable new applications, uh, and you can enable better solutions for the problem. Okay, please go through these slides by yourself. And what is most important for you is that it will help you to get a good job, because if you know computer architecture well or systems engineering well, and most of the companies that I see today, including Amazon or Cisco or Juniper or Brocade or many others, they all of them use computer architect. They have their computer architecture of their own, which you may not see from outside. Say, for example, Amazon create main business of Amazon, of course, is cloud creation and application on that. How do you create cloud? You in cloud you have millions of computers put together, right? And then there is a these are basic microprocessor running, right? So and that will have some kind of OS, right? And it will be distributed OS. You'll decide how to do routing within that network and so on and so forth. So there is a whole architecture inside that's not visible to us. See, when we do simple Google query, how does it actually execute inside a data center? Right? It is very interesting that one simple query, you search your name, it and it forks into you know 10,000s of the tasks, and that run parallelly, really, and data is collected, and result is presented to you, right? So it's all hidden from us, right? But how do you design a data center is very important design problem, right? And it totally depends on what architecture we decide for data center and what processor or microprocessor use, what networking we use, and so on. All right, another 10 minutes, then we'll have some question and answers. So now this is the syllabus that we are going to cover. Okay, we'll start with basics. We'll go to computer von Neumann architecture. We'll look at what is inside a system. We'll look at basic computer arithmetic. Now you would have done some of this arithmetic in your logic course. Uh, okay, your digital electronics course, but we'll do these again because I will give you some problem to solve to you, and then we'll see whether with the limitations of data types can you do this, and what are those limitations. We'll also study MIPS architecture, uh, then how actually data path is created inside a microprocessor and how control path is created. So we call this as actually micro architecture, something that is below instruction set. Okay, we'll look at single cycle design, multiple cycle design. We'll look at deep pipelines, branch prediction, etc. We'll go to memory hierarchy, virtual memory, I/O system, multi-core and multiprocessor architecture. I'm not sure if you guys have covered Ethernet in your networking course. If you have not covered, then we can cover this also. Similarly, if VM you have not covered so far, we'll look at VMs because VMs becomes the basis for data center, right? So we'll look at that. And if time permits, then we'll cover Bitcoin and blockchain architecture. Blockchain architecture very interesting from security perspective, as well as the new way of doing transactions. And then if still we have one or two lectures left out, then we'll cover cloud and data center architecture. Okay. Now these two areas are very important in order to get a job. Okay, because I am approached by some companies and they want to take people who have worked on blockchain architectures. Obviously, it's very difficult to find people, students at least, who have not covered this, who have not done programming on blockchain architecture, but still we'll look at some basic things. Okay, My expectation is that you will attend all classes. See, my motivation is to give you learning. My motivation is not the motivation of other teachers that we have. Uh, because it's not my career thing. My career is all done. I'm doing it for fun. Okay, and this is just to give back to society. Okay, so if you're not serious about it, then it will not help me. So my expectation is just to you need to attend the classes. If you want me to repeat the class, I will repeat it. Okay, but you have to make an effort. Okay, you cannot sleep in the class. I'm telling you because I have experience of student actually sleeping in the class. Okay, and this is not good. This is not good, right? Because we don't have too many choices in life, right? We for anything, if you look at it, we have choice of doing it well or choice of not doing it well, right? We have choice of attending class, not attending class. We have choice of being attentive in the course or sleep in the course. We have choice of throwing something or keeping something. We have choice of being aware of something or not aware of something, right? We have choice of not daydreaming and knowing what we are doing versus daydreaming. So if you just switch yourself from daydreaming to non-daydreaming, then job is done. Okay. This is the attitude that we need to develop. Okay, so I request you to please help me in this. So in case you have any difficulty in understanding any topic, please reach me at any point in time. And whatever I know, I will tell you. I cannot claim that I am, the expert in this area because I'm teaching it after a long time. This course, almost 25 years. Um, so, but I will I will do hard work for this course. So I do expect you to help me. Now, programming language very well. So the whole aspect of designing this course is to do more programming and assignments than actually learning theoretically. Okay. And my expectation is that you will have to do things by yourself, right? I mean, please don't cheat. Don't copy assignments. Even if you don't do it, I'm okay with that. If you say that I'm doing it late or I couldn't get time, I will do it. All these excuses are fine with me. Even if you get less marks, I am fine with it. And if you want me to give good grade despite that, I will give you. But if I find that you have or someone has copied assignment from somebody else, both people, will get 0 marks or fail grade, right? So please don't do that. I'm okay to help you out whatever you want, but copying solution from internet, cutting, pasting, all this is not acceptable, right? Because it defeats the objective of learning. Uh, and all of you are smart students, right? I mean, crack through JEE, so it's not easy. So please uh, follow this. And what do you expect from this course? Please send me details. I mean, uh, what is your expectation? Please go through slides, and if you want me to cover something else apart from this, or you want to do more assignments, more exercises, I'm fine. Less of teaching, more of assignment, that's also fine. Please let me know about it, right? And please give me feedback continuously that things are not moving right, pace is fast, you are absolutely boring teacher, I have not seen anybody like you, all that, everything is fine. But I need feedback at right time, okay, such that I can make corrections to make this course interesting. Okay? All right. So teaching assistant for this course and lab is Pavitra. Pavitra, are you there?
Yes, I am there.
Okay, so
Yes.
Pavitra is doing PhD with Sharad, and Pavitra has done this course before. She has helped Sharad into the lab, right? So she will be helping you with your assignments and also corrections. Yeah,
Hmm.
maybe tomorrow we have lab class, so I will start with the lecture in general, and then once we cover few topics in the course, then you will get more assignments, lab assignments. And meanwhile, I think I will give you some C coding to do based on, of course, on architecture.